Welcome back to another wonderful section of this wonderful tutorial class. Today we are going to be looking at the topic motion. We'll be looking at the equations of motion precisely. Now, though you have not subscribed to this channel, please try to do so now. And please don't distract yourself by any means. And please, this is physics, and you know that this class is very authentic. So for you to get the full details of everything you are going to be explaining in this class, what you have to do is just to keep yourself away from distractions. Any form of distraction at all, please keep yourself away from them. And please don't skip any part of this video at all. Don't skip any part of the video, because every moment, every second of this video is very, very important. So don't skip any second. Don't say, let me skip this part. No. Watch this video to the end and watch yourself being upgraded and improved when it comes to knowledge, because you're going to gain a lot from this place. So your knowledge will be increased after this class. I'm very sure of that. So just distance yourself away from distractions and watch this video to the end. That is the two vital things here. And in case you have any question, we have our comment section there. You are free to write your questions, ask your questions in our comment section, or watch this video over and over again. Because I know if you watch it over and over again, you will get that question you are trying to ask. You will get it definitely. So just watch it, because that is one of the opportunity of these classes. This class you're seeing here. Because anything you don't understand, you have the something like opportunity to go back, rewind the video backwards, and watch the scheme again to get it more. Because the more you watch it, the more the understanding will be coming. So let's look at this topic now, which is the equations of motion. Now, we said in the last class that motion is the change of position of a body. When a body changes its position with time, we call it motion. And the study of motion without taking regards to the forces causing the motion, we call that part of mechanics kinematics, which we were trying to. This time we are saying kinematics now, because we are studying motion with no regards to the forces causing this motion we're talking about. So please, what do we use if you want to describe the motion of the body, or the quantities used if you are trying to describe this change in position of the body or change of position of the body? We use the following quantities, which I mentioned in the last class, which are, number one, we can use the displacement of the body, or we can also use the distance moved by the body. Remember, displacement is a distance move in a specific direction. So when your distance is having a specified direction, we call such distance displacement. Yeah, take note of that. Now, we can also look at the velocity of the body or the speed of the body. Now, speed we associate with distance move over time, while velocity we associate with displacement move over time. Then we also look at the time taken to change that position and the acceleration of that body as well. Acceleration is the change in velocity of the body with respect to time. So please, note these quantities: the speed of the body, velocity of the body, the distance moved, the displacement of the body, the time, and the acceleration. We're using these quantities to describe the motion of a body. Now, if we now look at the interrelationship, or how these quantities are correlated, we now call such relationship equations of a motion. Equation of what? Motion. Now, if you look at this four equations we have here, mainly we have three of them. This 1, 2, 3. Because if you further express this one, you're going to have this. If you take this step to be b minus c over a, and you express it very well, you're going to have b squared equals to u squared plus 2ax. That's what we're going to have. So basically we have 1, 2, three equations of motion. I just added this to it. That's what we have here. Now, the first equation we have here is that, now, take note of the terms here. Anywhere you see V denotes the final velocity of the body. The final velocity of the body. Then, if you see anything U denotes the initial velocity of the body. That is the original velocity of the body. Then, A denotes acceleration, which is the change in velocity relative to time. Then T denotes time. T denotes time. The X denotes either distance or displacement. And you call it distance or you call it displacement. And there's another thing there. So the final velocity of the body from equation 1 is that the final velocity of the body must be equal to the initial velocity plus acceleration times time, which is V is equal to U plus AT. Equation 2, the displacement or the distance moved by body must be equal to the initial velocity times time plus half the acceleration times the time squared. So X is equal to U T plus what? Half AT squared. That's the second equation. Then the third one is V squared is equal to U squared plus 2AX. Then this last one is not actually equation of motion per se. These are just from average speed. Average the distance move when you know the average speed of a particular body. So this one will be the average speed times time. And also is average speed. V plus U over 2 is average speed times time. Now if you express this one in the sense that you will take this T as make T formula here, use this and have V minus U over A. Then you call this T V minus U over A and express it very well. You're going to have this third equation. So this one is just like part of this. So the major three equations of motion are just this, and this. A linear motion, constant acceleration. Now, let's look at some worked examples you can use these equations for. Now, let's look at this first question. Now, what will be the final velocity of a car? What will be the final velocity of a car? What will be the final velocity of a car? Whose initial velocity was 20 meters per second? Whose initial velocity was 20 meters per second? And accelerated with a rate of 10 meters per second square. Rate of 10 meters per second square in 5 seconds. And accelerated rate of 10 meters per second square in 5 seconds. I read again, what will be the final velocity of a car? Whose initial velocity was what? 20 meters per second. And accelerated at the rate of what? 10 meters per second square in what? In 5 seconds. Without wasting time, the initial velocity of this body, we said the initial velocity was what? 20 meters per second. The acceleration is 10 meters per second square. And the time is what? The time is 5 seconds. Then what will be the final velocity of this one? Now, check the equation of motion. What is the relationship between V, U, A, and T? Equation 1. That V is equals to U plus AT. This relates V, U, A, and T together. So, we are looking for V, which is the final velocity. So, on substituting now, we're going to have 20 plus 10 times 5. That will be equal to 20 plus 50. That's equal to 70 meters per second. That will be the final velocity of that car. That will be the final velocity of that car. Now, let's look at another question. Let's look at another question. Well, let's look at another question. Obtain the distance moved by a body. Obtain the distance moved by a body whose initial speed was 5 meters per second. Whose initial speed was 5 meters per second and accelerated at the rate of 2 meters per second square and accelerated at the rate of 2 meters per second square for 10 seconds. For 10 seconds. What will be the distance moved by the body? Or will be the distance moved by the body? Whose initial speed was what? 5 meters per second and accelerated at the rate of 2 meters per second square for what? 10 seconds. Now, what are we looking for? Initial speed. Remember, when a velocity don't have direction, we call it speed. So the initial speed is 5 meters per second. Acceleration is equal to 2 meters per second square, and time is what? 10 meters per second. 10 seconds. Sorry about that. The time is 10 seconds. So, what will be the distance moved by this body? Since we are talking about speed, we should be talking about a distance moved by that body. So, distance moved will be, let's look at the equation. Final velocity is 1 known. But the initial velocity, equation 2, will work here. So, our x will be equal to ut plus half at squared. That will be equal to u. What is u here? U is 5 times 10 plus half times, the equation is 2 times 10 squared. So if you do this very well, you are going to have something like our 50 plus 2 will cancel 2. 10 squared will be 100. That will be 150 meters. That is 150 meters. So that is the distance moved by that body. That is the distance moved by that body. Now let's look at another question. Let's look at another question. A car initially at rest. Another question. A car initially at rest and accelerated 0.5 meter per second square and accelerated 0.5 meter per second square and covers a distance of 20 meters. And covers a distance of 20 meters. Calculate the time taken. Calculate the time taken for the car to cover this distance. Calculate the time taken for this car to cover this distance. If the car started what? From rest and is accelerating at the rate of what? 0.5 meters per second square and cover this distance, what time will it take this car to cover this 20 meters per second square? Now, anytime you hear something rest, if a body is starting from rest, it shows that rest is telling us that initial velocity is 0 meters per second. That's what the rest is telling us. So anytime you hear this thing started from rest, now that it started from rest is telling you that the initial velocity of that body is what? Is 0. That's what you should know. So our acceleration is this and our distance is this. What will be the time to cover that distance? This equation will still work, which is S is equals to ut plus what? Half at squared. Now what are we looking for? We're looking at our t here. Now let's include the values. We have 20 is equals to 0 times t plus half times 0.5 times t squared. So we have 20 is equals to, this one will be 0. That will be 0 plus half times 0.5. That will be 0. Okay. Remember, 0.5 is empty as 1 over 2 times is empty as 1 over 2. Then t squared. So 1 over 2 times 1 over 2 gives us 1 over 4. So we do something like this. This will be 0. We have 1 over 4 t squared. 1 over 4 2 squared. So let's see, cross multiply. We will multiply. When we write that, we're going to have 20 times. Okay, any of us express it very well. I have 20 times 1 over 4 t squared. So if you multiply this to this, you're going to have 20 times 4, 4 times this one, equals to t squared. So what is 20 times 4? 20 times 4 is 80. So our t squared will be equal to 80. So take the square of both sides. You square this side, so square the other side. Take the square root of both sides. Take the square root of this side, take the square root of this one, cancel this. And t will be equal to 80 seconds. So root of 80. Alright, take this question down. Let's look at this question. Next question. Let's look at this question. Question is, what distance is required to stop a car? What distance is required to stop a car? What distance is required to stop a car? Moving at the rate of 108 kilometer per hour. Moving at the rate of 108 kilometer per hour. Moving at the rate of 108 kilometer per hour. If the driver's reaction time, is 0.1 seconds. If the driver's reaction time is 0.1 seconds. So what would distance be required to stop that car there? So now the initial velocity of the body, is u, which is 108 kilometers per hour. Now we're going to move this one to meters per second. So we are going to have 108 times. What is your kilometers in meters? You have to multiply by 1000. That's how to convert kilometers to meters. The amount to convert hour to seconds, multiply 60 times 160. That's how to convert hour to seconds. That's how to convert hour to what? To seconds. So if you do this very well, let's see, this 0 cancel this 0, this 0 cancel this 0. So we're going to be having, it's going to be seconds. So we're going to be having 108 over 36. 108 over 36. So if you solve this, let's see what I'm going to have. Solve that, let's see what I'm going to have. Then you'll be having 30 meters per second for the initial velocity or initial speed of the body. Then the final speed is that the body is going to stop. The body is going to stop. You say what distance is going to stop the car? So if the initial speed is this one, the final speed is that the body is not moving again. That will be 0 meters per second. The body will stop. Then the time taken for this body to stop, the general reaction time is 0.1 seconds. Then let's see what we're going to have. We know that V is equals to U plus 80. And let's look at the acceleration of the body. The deceleration of the body is negative acceleration. Let's look at the deceleration of the body now. Deceleration of the body now, we're going to have V minus U over T is equals to A. So that gives us our A to be equal to 0 minus 30 over 0.1. That will be equal to minus 300 meters per second squared. So that is 300 magnitude. The magnitude is 300 meters per second squared. And this one is not as accelerating upward, is accelerating downward. That's called deceleration. This is decelerating. And that's how you are having there. So this equation, the equation of motion is V squared is equals to U squared plus 2AX. Then we're going to be having our distance to be equal to, or S will now be equal to, put on the other side, we're going to have V square minus U square over 2A. This will be equal to minus 0 square minus 30 square. That will be equal to 2 times 300, then equal to So remember, this was negative 4. So now it's negative 4, which it is negative. So we're going to have minus 900. That is 30 to give us 900. That's 30 times 30 over minus 600. I'll cancel this. Cancel this. So 2, 3 here. 3. 3 here. 2. That's 1.5 meters. So that's the distance. You can to stop that calculate is 1.5 meters. So that's what we're going to have. Now we can use this other equation, which is which will also work. S is equal to U plus V over 2 times T. That is which is 0. Okay, this one is 30 plus 0 over 2 times 0.1. So just work. Guys, I think you can also use this to get this answer, as I'm trying to say. You can also use this equation to get the answer, which is the first one, which is 1. That is 15. Let's think about this 15 times 0.5. That will give you 1.5 meters. So you take the average speed, which is the final plus the initial divided by 2. So you can also use that to get an answer. The study of that is very, very important. So that it must not be this long. So use that to get that answer. Now, let's look at another question. Next question. Now let's start this question. A body starts from rest and travels 90 meters. In the 5th second. Travel 90 meters in the 5th second. Travel 90 meters in the 5th second. Calculate the acceleration of the body. And the velocity after 10 seconds. Calculate the acceleration of the body. The distance moved is 90 meters. And the time to move this distance is in the 5th second. Now, this 5th second is a type of time in a motion given in terms of position, which is the 5th second. Now, the other time that calculate the velocity after 10 seconds, now is the value. So, this is another question in which time will be given in terms of position. So, we are told to calculate the acceleration of this body that travels 90 meters in the 5th seconds. And 5th seconds, to express 5th seconds, you take T5 minus T4. T5 is 5, T4 is 4. The value for T5 is 5. At T5 time is 5, then at T4 time is 4. That's the expression. So if you head like 5th seconds, what you have to do, just remove the initial time, which is 4 from the final, which is 5. Here 6 seconds. Remove the initial, like the preceding number to 6, which is 5 from 6. Here 7 seconds. Remove 6 from 7, just like that. Just from 6 to 7, that's the final and the initial, something like that. I say 5th, we will move from 4 to 5. 4 to 5, the final is 5, the initial is 4. That's T5 minus T4. So we know that x is equal to 1 relate time, acceleration and distance, x is equal to ut plus half at squared. But we know that in this question, they said it started from rest. The body started from rest and traveled 90 meters. So if the body started from rest, u will be 0 meter per second. So I'll use 0 t plus half at squared. So this one will leave. Our s will not be. Now s is 90. Then we have half times a. What is a? That's what we are looking at to see what is the acceleration of the body. Then our time, which is 6 seconds, is 5 to what? To 4. From 4 to 5, that is 5 minus 4. This one will give us this times this. That is 2 times 9 to give us 180 equals to a times 5 minus 4 will give us 9. So the next thing we are going to do here, we're going to have our 9a is equals to 180. And we divide both sides by 9, so we cancel this. A will be 20 meters per second squared. That's what we're going to have. The acceleration of the body is 20 meters per second squared. Then, what about the velocity after first seconds? What is the v? What will be the v now? What is the final velocity at time equal to velocity after 10 seconds? At time equal to 10 seconds. What will be the velocity at time equal to 10 seconds now? If we started from rest, we know the acceleration of the body is 20 meters per second squared. What will be the speed or what will be the velocity of the body at a time of 10 seconds? So we know that v is equal to u plus 80. Now u here is 0. We're going to start from rest. Now 0 plus a is 20 times 10. That will be equal to 200 meters per second. That is the velocity of the body after 10 seconds. That is the velocity of the body after 10 seconds. So let's look at another question like this. Let's look at another question of this nature. Another question of this nature. Let's say a body started from rest with acceleration of 15 meters per second squared. With acceleration of 15 meters per second squared. With acceleration of 15 meters per second squared. Calculate the distance moved by this body. Calculate the distance moved by this body in the 5th second. Calculate the distance moved by this body in the 5th second. What will be the distance moved in the 5th second? Is t 5 minus t4. Just did. The 5th second. So let's start. What are we going to have here? What to solve that now? How are we going to go into that? We know that displacement is equal to when it started from rest. When it started from rest, u is 0 meters per second. Is 0. So we have ut plus half at squared. Then if this one is 0, then this one will be reduced to half at squared. So that will be a is 15. We will have half times 15 times t is from 5 and 4. So I will have 5 squared minus 4 squared. I have expressed 50 seconds. And it was 1 over 2 times 15 times 9. So if you solve this, what are we going to have? We'll be having 67.5 meters. We'll be having 67.5 meters. Now let's look at this other question. Look at this other next question. The next question is a body starts from rest and travels 90 meters. And travels 90 meters in the 5th second. In the 5th second. And travels 90 meters in the 5th second. Travel 90 meters is 5th seconds. Calculate the distance moved by this body in the 7th second. Calculate the distance moved by this body in the 7th second. I don't know if you understand the question. The distance moved in the 5th second is 90 meters. What will be the distance moved in the 7th second? Calculate the distance moved by this body in the 7th second. So let's see how to solve this question now. This question is going to be very lovely. Because it's distance you are looking at. But remember, if we start from rest, our u is equal to 0 meters per second. That is it. When we started from rest. So what will be the distance moved now in the 7th seconds? Now, in this place now, let's for the acceleration of the body first. That's the first thing. We can get the acceleration, we can get the distance moved in 7 seconds. Know that s is equals to ut plus half at squared. Then if this u is 0, everything here will leave, we have half at squared. So our x is 90, and we have half times a times, for 5 seconds, we're going to have 5 squared minus 4 squared. That's for 5 seconds. Then this was what we did before. In this class, I will have our A to B. Let me just do this again. 180 was equal to 9A. Then our A was equal to, if I use both sides by 9, we have A to be equal to 20 meters per second squared. We solve the question, we solve this question for exactly something like this. Now, if A is 20 meters per second squared, if A is 20 meters per second squared, what will be X at the 7 seconds? What will be the S at the 7 seconds? What will be the displacement at the 7 seconds? And 7 seconds is T7 minus what? T6. That is 7 seconds. For T7, the time is 7. For T6, we have 6 there. So what will be the displacement at the T? We have that X is equal to ut plus what? Half at squared. If the body is starting from rest, u is 0, we have half at squared. So therefore, the displacement or the distance moved in 7 seconds will be half times 20 times 7 squared minus 6 squared. That will be equal to 10 times 7 squared is 49 minus 36. 9 minus 36. So do that, you have 10 times 3, 13. You have 10 times 13, and that will give us 130 meters. That is the distance moved in the 7 seconds, 130 meters. So please, I would like you to solve this one for me now. Try and solve this question as classwork. Try and solve this question as classwork. So ensure you watch this video over again. You have to get the full details about this class. It's very, very important. Very, very, very important. Now, let's look at this question. A body starts from rest with an acceleration of 0.5 meters per second squared. With an acceleration of 0.5 meters per second squared. An acceleration of 0.5 meters per second squared. And covers a distance of 25 meters. And cover a distance of 25 meters. Obtain the time taken to cover that distance. Obtain the time taken to cover that distance. Obtain the time taken to cover that distance. So the time will be, solve that very well, time is going to be 10 seconds. 10 seconds. That is the time taken to cover such distance. Time taken to cover such distance is 10 seconds. So please solve this question. And if you have any question, just there's anything you don't understand, you can watch the video over and over again. Then if there is anything that you don't understand, just drop it in the comment section. Then we'll look at it and get back to you. So see you guys in our next class. God bless you. I love you. Thank you.